Okay, this screencast is going to take you through Module 2, Lesson 4, which is all about creating and solving inequalities. So down here, it says that an inequality is a statement that compares two expressions that are not strictly equal by using one of the following inequality signs. Okay, guys, so basically you have equations, which you'll use an equal sign with, and you have inequalities, which you'll use one of these other symbols. All right, and we read them kind of left to right. So this over here has to be less than this over here. So this is a less than sign. This is less than or equal to. Greater than is greater than or equal to, and then this symbol just means it's not equal to. You guys have probably been to an amusement park at some point in your life, and you may have seen a ride that says you must be at least 48 inches tall to ride this ride. So that would be a statement written like this: height must be greater than that part or equal to 48 inches, meaning you've got to be at least 48 inches to ride that ride. Okay? So let's just break right in and start doing and walking through some of these examples. Just remember, anything I do in the video you need to do, because I am helping you with the examples in the lesson. All right, it says that Nora's planning a birthday party for her little sister Colleen, and Nora's budget will allow her to spend no more than $50 for party supplies. Okay? So already I'm kind of mentally saying to myself, she pays something that's less than or equal to $50. Okay? Is less than or equal to is what I'm going to use in my equation. 8 children, including Colleen, will attend the party, and Nora wants to determine how much she should spend on party favors for each child. She will also purchase a cake for $10. So write an inequality that it represents the situation and find possible solutions. Well, first of all, we had a little bit of debate in class as to whether Colleen, as the party recipient, would also receive a party favor. And so we decided, no, that's not what they meant. So party favors are just for the people she invites. So Colleen has 8 friends that are going to come attend the party. So the cost of 8 party favors, so cost of 8 party favors, plus the cost of a cake, which is $10. And then we're saying to ourselves, which inequality symbol should we use for no more than? Remember, we said she can't pay any more than $50, so it's that less than or equal to sign. All right, so we've got all of our little pieces. 8 party favors at a cost of C plus $10 for the cake has to be less than or equal to $50. Suppose Nora finds party favors that cost $4 each. Okay, use the value of 4 and check to see if this inequality is true. Well, 8 times 4 is 32. 32 plus 10 is $42. Is 42 less than or equal to $50? Yes. So, can Nora buy, let me scoot that up. Can Nora buy party favors for everybody for $4 each? Yes, $4 keeps her under budget. Okay? The inequality is true. $4 party favors. All right, so now I'm at the top of page 78. So is the inequality true? We're still talking about Nora throwing the little birthday party for her sister Colleen. And we said, yes, the inequality is true if she uses $4 party favors. Okay. Could Nora buy $6 party favors for all of her guests without going over budget? Well, we're going to go back and take the original equation, which is 8c plus 10 is less than or equal to 50. And if the cost is $6, then that's going to be 8 times 6 plus 10, and we want to know, is that less than or equal to 50? Well, 8 times 6 is 48. 48 plus 10 is going to be 58, and that is too much because 58 is not less than $50. So, can she buy $6 party favors without going over budget? No. $6 party favors would put her over budget. Okay? Why does an inequality represent Nora's budget calculation better than an equation? Well, because there's a range of possibilities of what Nora could get. So she could buy party favors that were $4.99. If you put it in there, you're still slightly over budget. Obviously, you can buy party favors that are $4, for $3, for $2, whatever. So there's a range of costs that are acceptable for Nora's budget. So there's more than just one way of dealing with Nora's budget constraints. Okay? So let's go down here. Describe the whole dollar amounts that are in the solution set for this equation. Well, so I would go 8c plus 10 is less than or equal to 50. I'm going to solve for c. Minus 10, minus 10. I have 8c is now less than or equal to 40. Divide both sides by 8. C must be less than or equal to $5. So the solution set is anything less than $5 is what that means. Okay? Okay. So you may need to use the distributive property before you can solve an inequality. Just remember that the distributive property says that if a, b, and c are real numbers, then a times the b and c, b plus c in parentheses, is the same as a times b plus a times c. Okay? This is really important. The inequality sign must be reversed when you are multiplying or dividing both of the sides of an inequality by a negative number. Keep that in mind. All right, let's just look at example 1. They've done it for us, but let's just talk ourselves through it. Trina is buying 12 shirts for a drama club. She will choose a style for the blank shirts and then pay an additional charge of $2.75 for each shirt to have the club logo. If Trina cannot spend any more than $99, how much can she spend on each blank shirt? So write and solve an inequality to find the possible cost of each blank shirt. Well, first we've got to pick a variable, and they're just going to say let S represent the cost of each blank shirt. And then write an inequality. Well, we have 12 shirts, and if we read the problem carefully, each shirt is the cost of the shirt that's blank, so the cost of a blank shirt, plus the $2.75 for the logo. So blank shirt plus the logo cost, you've got 12 of them, and you've got to stay at 99 or under. Okay, so that's why they wrote the equation that way. And then you'll use the distributive property to distribute out the 12. And when you do that, 12 times S becomes 12S. 12 times 2.75 becomes 33. And then you just solve for S step by step. And you can't pay any more than $5.50. So the cost of the shirt has to be $5.50 or less. Okay, so just to let you see this a slightly different way. All of this in here is an equation that represents the amount of money she can spend. Okay, and the amount of money she can spend has to be less than or equal to $99. And when you get all the way down, that $5.50 at the end is $5.50. It's a price. Okay, and that's all she can spend per shirt for the blank shirt because she's got to spend $2.75 each to get the logo put on there. All right, and it says, I'm on the top of page 79 now. It says check your answer. So since S has to be less than or equal to $5.50, put a smaller number in there and check to see that it makes a true statement. So they picked, what if the shirt only cost $5? Well, you do all the math. 12 times 5 plus 12 times 2.75, you get all that, and that's $93. So $93 is less than or equal to 99. So that should be correct. I can put 550 in here. And when I put 550 in here, it should say 99 is less than or equal to 99, which is also true because it says less than or equal to. But anything over 550 is going to put you over budget. All right, Sergio. Sergio apparently has a lot of friends because it says Sergio needs to buy gifts for 8 friends. He wants to give the same gift to all of his friends, and he plans to have the gifts wrapped for an additional charge of $150 each. If Sergio spends at least $70, he will receive free shipping on his order. So write and solve an inequality to determine how much Sergio needs to spend on each gift in order to receive free shipping. So if he's going to spend at least $70, then what Sergio spends, before I even put in like an equation, I'm thinking Sergio spends at least $70, or what Sergio spends is greater than or equal to 70. Okay? And then write an inequality to represent the situation. G is going to be the cost of one gift, and the gift plus $1.50 because he's having to wrap it, and each one is $1.50 to wrap, and he's buying 8 gifts. So 8 times G plus 8 times $1.50, all of that has to be at least $70, so greater than or equal to 70. So when you do that, 8G plus 8 times 1.5, that's 12. And there's my 8G again. So 8G plus 12. And then to move the 12, I'm going to say minus 12 and minus 12 on this side. And that cancels out the 12 there. And you get 8G is equal to, or sorry, is greater than or equal to 58. To get G, I'm going to divide both sides by 8. Divide by 8. Okay. All right. And when I divide both sides by 8, G is going to be $7.25. 56 divided by 8 is an even 7. So I know it's a little bit more than 7. Okay. And then check your answer. Since G is greater than or equal to $7.25, pick a larger number. So let's say we pick a gift that's $8 a piece. Well, 8 times 8 is 64, plus 8 times $1.50, which is another 12. Those two together are, I guess, 76. And 76 is greater than or equal to $70. Okay, so Sergio must spend at least $7.25 on each gift.